Okay, welcome back to this Chrono Quick Talk, and I'll talk about blued screws. And why I choose blued screws to talk about. It seems to be a not very interesting subject because probably all of you already seen a movement with blued screws, and you probably already know how blued screws are made, how they are blued. But I know that there is a little bit more than that, and most people don't know what is this blue film that forms over the surface of the steel and why it was like that in first place. And there is actually a technical reason for that. First thing to keep in mind is that screws are parts that are subject to stresses. It's a part that is you have to apply torque when you are screwing in, and it have to keep a certain amount of force to be kept in place, because the screws are responsible to keep parts in place and to keep parts together, so it have to be in a constant amount of stress, a constant amount of tension. And for that reason, screws have to be made with resistant materials. And one of the ideal materials to do that is steel. Usually it's not stainless steel like the steel used on watch cases and bracelets. And in case you didn't watch, you will see a card here of a video when I talk about steel used to make watches. And in the case of the screws, is more or less regular steel, and you have to be subject to a process to make it harder and to give it more strength. The first process is the hardening of the screw, or also known as quenching. It comprises of subjecting the screw to a very high temperature, which is around 700, 800, or even 900 Celsius degrees, and then subjecting to immediate cooling is a thermal shock. And this process makes the steel very hard, but it also creates a certain undesirable tension within the material. And this undesirable tension may lead to cracks on the material, especially when you are screwing the screw. And that's why you need to temper the material after the hardening. And the tempering is the process of heating the material up, but not as high as or as hot as you do to the hardening. But you still have to submit the material to something around 290 degrees Celsius, which is the adequate temperature to temper a screw used to watches. At this temperature, you actually release the undesirable tension within the material and makes it adequately hard and tough to that application. But what also happens is that during the process of tempering, the surface of the material starts to form a passivation layer. And in this video, I explained a little bit about passivation layer and what it is and what it does. And when you are tempering the hardened steel, it starts to form a layer of magnetite. It's an oxide. It's not the same oxide as rust. It's a different, very similar but different composition. It's a very stable oxide, and it's a mineral. It's magnetite, and it starts to form on the surface of the screw as the temperature is rising. So it starts to turn yellow, then starts to turn into an orange, and then red, and then brown, and then a very dark purple. Then it starts to turn dark blue, and then it starts to lighten up until a very light blue. And this change of color is actually because this passivation layer starts to grow up and starts to get thicker and thicker, and as it gets thicker, it starts to filter the frequencies of light on the natural light, and it starts to reflect only certain frequencies. So at around 290 degrees, it have a certain thickness that only reflects the dark blue light, and that's why the appearance of the material gets this dark blue, which is absolutely beautiful. But it's actually a kind of a coincidence that the ideal temperature to temper a screw of a watch is also the temperature that gives that beautiful dark blue color. And also there is a second reason, but this is debatable, that is this blue passivation layer actually creates a kind of a film that protects the material from oxidation or rust. This is a little bit controversial because I already read some documents saying that this magnetite is actually porous, and it actually allows the oxygen to be in contact with the steel, and because of that it doesn't protect the material at all. But in the other hand, the classical watchmaking literature, the classical watchmaking books states explicitly that bluening also makes the surface of the materials more resistant to rust or oxidation. Well, it's just what I read. I cannot decide if what is right or wrong, but this is debatable. But anyway, there is a technical reason for screws to be blue, and it's a result of the tempering. And that's it. I believe that most of you didn't know about this, and I hope you like it. I hope you learned something new, and stay tuned.